Hey all dear GATE aspirants, this is Abhinav Sir and I welcome you all in this inauguration session or the first session of the Formula Marathon series. So guys, before going to the formula of Geotechnical Engineering, I'll be completing soil and foundation today only in a single shot. Before going in this formula revision, let me describe you about this series, what this Formula 1 series will be and how we will be dealing with this series and what content we are giving here in this particular series of Formula 1 revision. Guys, let me make you one thing clear that just a couple of weeks before, I guess on 4th of January, we have started the complete marathon series. Okay, in those particular sessions, we have done the marathons of each and every subject, and here we are doing the each and every subject formula revision. Okay, the difference will be in that particular series. Okay guys, concepts plus derivation plus numerical, everything will be there, but this particular session will be there. This particular series will be related to only and only formula, nothing else. Let me just give you an example, like the discharge is Q is equal to K into H into NF by ND. So here I'll be telling you what is the K, what is H, what is NF, what is ND, and how twist can become in that formula. Okay, I'm not going to derive that formula here right now. Okay, that we have done there in the marathon series. Okay, so I guess just before the examination, before the GATE examination, this is very important for all of you. You have done the preparation from last many months and might be some formula you have forgotten till now. So Jatin, Prince, everybody, this is a particular formula session. Okay, so guys, this is about me. My name is Abhinav Sir, having 11 plus years of teaching experience, done my MTech from IIT Delhi in Geotechnical Engineering. The same thing we are doing right now, the same session we are doing right now in which I have done my MTech. Okay, so guys, you can join me in Telegram, Civil by Abhinav Sir Telegram group. More than 4,000 students have already joined that, and you can also join that. Okay, I'll sharing this sessions PDF also there. So guys, along with the formula revision, we have a prediction series also where we are discussing the 10 most expected question. Like tomorrow I'll be coming with surveying, which I have already done environmental engineering. Now I'll be doing with surveying. Okay, tomorrow I guess 8:30 9 p.m. I'll share that in my Telegram. Okay, here we'll be dealing with most expected 10 questions. Okay, Bhaskar, how was the exam? So Bhaskar, how was the examination? Whatever we have taught you, how much things have been coming from those things. Okay, so this is the prediction series. Every day guys, you will be having a prediction series also and F1 series also, except Sundays. So here tomorrow will be this, then 23, 24, 25, 26, every day will be a session on the subject. Okay, what are the most expected question, and this is the Formula 1 series. I am starting right now today this, that is Geotechnical Engineering, then ma'am will be coming with the environmental engineering tomorrow. Okay, so this is the complete schedule. Every day, 22nd, 23rd, 24th, 25th, 27th, every day this will be there, and on 26th we'll be having the mega mock challenge. Guys, if I talk about today's session, then Geotechnical is coming around 14 to 15 marks. Okay, it is not one of the highest subjects or highest weightage subject in the civil engineering, it is the highest weightage. This will be on 26th. You have done the mock test today only. Okay, I was in Patiala guys yesterday. There is some unfortunate incidents happened to my family, so I have to visit to Patiala. I traveled to the Patiala, drive there, and then I came just 1 hour before. Okay, so that's why I was not able to attend the today's mock test, but yes, on 26th I'll be there. On 26th of January I'll be there. Okay, this is guys on Mega Marathon 27, 28, 29th. So whatever the non-tech part, apart from technical, okay, so whether it is English, maths or general ability, that will be on the Mega Marathon of 27, 28, 29. So please guys, book your seats. Okay, this will be on YouTube only on this particular session. Okay, so okay Bhaskar. Okay, I hope you make it. So guys, this will be the series after the GATE examination, the non-tech series for the engineering service students. So guys, you can see that Geotechnical is around 14 to 15 or 16 marks. It is not highest, it is one of the highest. Okay, so Geotech, environment, transportation from last 5 years are the highest weightages. Okay, If I talk now inside the geotech, the most asked question is this one, the class soil water relationship, that is the phase diagram. Okay, and all these relations between different parameters. Okay, then the seepage is also important, shear strength, and then the shallow foundation. These 4 chapters are most important. First one, that phase diagram wala chapter, then seepage, then shear strength, and then the shallow foundation. If I talk about the syllabus in last 2021, okay, after 2021 nothing was changed. In 2021 what was happened, that lateral capacity of pile topic has been added. Okay, and in this there are various theories. Let me tell you guys, you will be lost in the sea. There are so many theories. You just have to focus on Matlock and Rees theory. Matlock and Rees theory. Okay, there are some empirical relations from which you can find the lateral capacity of pile. There is spring analogy model, Terzaghi model, but you have to focus on Matlock and Rees. So this is the thing that has been added in GATE syllabus, and origin of soil has been removed. That how the physical weathering is happened, chemical weathering is happened, that has been removed. Soil structure, that is kaolite, eolite, montmorillonite mineral has been removed. Okay, many are saying that Darcy law is also removed. Guys, without Darcy, how seepage will be there? Okay, so Darcy is not removed, guys, and Westergaard theory is removed of the vertical stress. Okay, yes, they are in the, I am talking of GATE, they are in the ESE. Okay, okay. So guys, keep sharing, guys. This is the sequence in which we will be going to study this marathon, this Formula 1 series. Everybody on the comment section, guys, please put a heart sign. Are you ready? Are you ready, guys, for this Formula marathon? Please let me know. Please let me know. Everyone, are you ready? Let's begin with this series, guys. Come on, everyone. So guys, just put some josh here. I just reached, driving to Patiala yesterday, then coming back here just to take this session at time. Otherwise, I can come in night also. Okay. Excellent. Namaskar. So ready for this marathon? Okay, guys. Please, one small request from my side. Don't write anything on the copy and pen. Okay, whatever is written here, please don't write that, because anyhow I am giving that in my PDF in Civil by Abhinav Sir. Okay, this will be just 90 minutes maximum. Okay, this is not that marathon that I have taken couple of weeks before. This is only formula revision. Okay, if you want complete marathon, numericals also, if you want the derivation also, you can see that marathon. I will later on, I'll put that complete marathon link on this comment box. Okay, but here we are restricting ourselves only to the formula, not even the derivation. Okay, only the twist that can be asked from that. Okay, so are you ready, guys? Please. Okay, so let's begin with the first chapter, that is origin of soil and properties of soil. Okay, this is quicksand condition, we'll see later. Okay, if I talk about ESE, these topics are only in ESE. That kaolite, mineral, okay, and origin of soil, these topics are only in ESE. What are the white topics that is in GATE and ESE? So Arun, you came late today. Okay, but it's okay. Let's begin with the first chapter. Guys, let me tell you that anything less than 80 mm is soil. Okay, greater than 80 mm is not soil. Boulders or cobble is not soil. Only the things that are less than 80 mm are treated as soil. And now coming to less than 80 mm. So 80 mm to 4.75 mm, if the size is this, that is gravel. And 4.75 mm to 75 micron. 75 micron is 0.075 mm. That is, you can see that 1 micron is 10 to the power minus 3 mm. Okay, so you don't have to learn this. Coarse, medium, further bifurcations are not required. Only 4.75 to 75 micron, that is sand. And gravel and sands are coarse grain soil. Coarse grain soil has not any cohesion. Okay, coarse grain soil has no cohesion. They are angular in shape. Okay, the voids are bigger, but void ratio is smaller because number of voids are not that much big. In fine grain soil, the one void is very small, that is why permeability is also less, but number of voids are so much that void ratio, the volume of voids of fine grain soil is more. Okay, So 75 micron to 2 micron is silt, less than 2 micron is clay. These are called as fine grain soil, silt and clay, smaller in shape. Okay, here guys there is cohesion. Okay, they are particularly clay. If I say they are flaky shape, okay, and E, void ratio of fine grain soil is greater than void ratio of coarse grain soil. Okay, but permeability of coarse grain soil is greater than permeability of fine grain soil. Okay, because fine grain soil, there are small voids, so water is not able to move fast. Okay, in coarse grain soil, voids are bigger, so water moves fast, permeability will be more. But number of voids are so many in fine grain soil that void ratio becomes bigger there. Okay, Arun. Now, if I talk about, see, these are solids, little bit water, and where there is white color, that is air. Now, please guys, please find this, that voids is not only air. Voids is air plus water both. Void is air plus water both. Okay, and always remember this, when we excavate a soil and you throw somewhere, you make an embankment. Okay, suppose you take soil from my fields and you are making flyovers from that soil, then volume of solid will be same. Might be after compaction, volume of soil may be changed. If you compact the soil, volume of soil may be reduced, but volume of solids will be constant. Have you got it? Give me yes or no. Have you got it? Give me yes or no. Okay, so solids is constant. Solids is equal to constant. Okay, suppose you have a soil, you compress it, you think that volume is decreasing. Yes, total volume may be decreased, volume of voids may be decreased, but solid will be constant. This is dry soil. This is partially saturated, or you can say partially dry soil, and this is completely saturated soil. This is saturated soil. Now let us go to the formulas. Every commando. What is water content and moisture content represented by small w? Okay, this is weight of water. Guys, in whole soil mechanics, those who have studied from me from many months, they might be knowing this. I represent capital W as weight and small w as water content. Water content, moisture content, both are same thing. So water content is weight of water by weight of solid. Weight of water by weight of solid. If you want in percentage, then multiply by 100. If you want in percentage, then multiply by 100. And water content can be greater than 100%. Water content can be greater than 100%. Okay. Let me tell you example. Like there is a bentonite clay. Bentonite clay has so much voids. The voids are so much in bentonite clay. Voids are so much. So might be solid is this, and above is voids, and might be all voids are filled with water. Okay. So here weight of water may be more because there is so much water. So water content can be greater than 100%. Okay. Understood? Understood everyone? Understood everyone? Please let me know. Everybody, every commando, every champion, keep sharing guys. Because of you all, I come all the way 300 kilometers away. 300 kilometers I went yesterday to Patiala, then today here. Just half an hour before I reached here. Now what is void ratio? Void ratio is volume of voids by volume of solid. Okay, and volume of voids is this. Volume of voids is this, and this is volume of solid. Okay, and void ratio of fine grain soil or void ratio of sand is around 0.7 to 0.8, and fine grain soil has little bit more void ratio, 0.8 to 0.95, in this much range. Okay. Okay. So in between guys, I'll be telling you important things also. Don't worry about that. Now porosity is volume of voids by total volume. Porosity is volume of voids by total volume, and void ratio is volume of voids by volume of solid. Volume of voids by volume of solid. Okay, and void ratio is more important because here the or more stable parameter. You have seen many formulas of bearing capacity or anything else, differentiation, consolidation, anything. In all those formulas you use void ratio. In rarest of case you have used porosity. Okay, in rarest of case you have used porosity. In most of the formulas of bearing capacity, settlement, shear strength, you use void ratio because void ratio has in numerator are both same, volume of voids. Denominator is volume of solid. Solid is more stable parameter because solid does not change. Okay, total volume may change. If you compress, might be total volume is decreasing. Okay, y को derive कर देना. y को complete मैराथन में कर रखा है, उसको उसमें देख लेना. कोई डाउट हो मेरे टेलीग्राम में पूछना. ओके, सैचुरेशन क्या होता है? सैचुरेशन होता है, डाउट हो अरुण प्लीज पूछना, वॉल्यूम ऑफ वाटर बाय वॉल्यूम ऑफ वॉइड्स. ओके, ये एयर और वाटर, एयर एंड वाटर बोथ आर वॉइड्स एंड वाटर इज ओनली दिस मच. Water is only this much. Now what is void ratio here? What is saturation here? Saturation here is 0 because volume of water is 0. So here volume of water and volume of voids. So here S is in this range 0 to 1 and here S is equal to 1. Volume of water and volume of voids both are same thing. Volume of water and volume of voids both are same thing. Okay. Now moving further from here, every commando, air content. So air content is volume of air by total volume. Okay, and let me tell you one more important formula, that S plus AC is equal to 1. S plus AC is equal to 1. Okay, because S is volume of water by volume of voids, and air content is volume of air plus volume of voids, and when you add both of them, denominator is same, volume of voids. Volume of water plus volume of air, volume of water plus volume of air is volume of voids. Okay, so is equal to 1. Suppose saturation is 30%, so air content will be 70%. Suppose saturation is 82%, then air content will be 18%, like this. Now one more thing, that is percentage air void. Percentage air void is represented by Na, and it is equal to volume of air by total volume. If you want in percentage, multiplied by 100. If you want in percentage, then multiply by 100. Have you understood this, guys? Give me yes or no. Give me yes or no, everyone. Everyone, keep sharing, guys. Come on. Keep sharing, guys. Come on. Complete formula will be done today. Now, guys, these all things, bulk unit weight is represented by gamma T. Bulk unit weight represents that unit weight is weight by volume. Unit weight is weight by volume. So bulk unit weight means the unit weight of soil, whatever the case may be dry, may be partially saturated, may be completely saturated. So bulk unit weight represents the unit weight of soil upon volume of soil. Then unit weight of solid, gamma S. This is only the unit weight of solid, not whole soil. That is weight of solid upon volume of solid. See, density is mass by volume. Density is mass by volume. Okay, unit weight is weight by volume. Okay, unit weight is weight by volume. Unit weight is weight, like density is mass by volume, unit weight is weight by volume. Good evening, Rishabh Pant and everyone, guys. Please keep sharing this. Okay, unit weight of water means weight of water by volume of water. Dry unit weight of soil means weight of dry soil upon volume of that soil. So weight of dry soil will be weight of solid only, because in case of dry this will be gone and air weight is taken as 0. So okay, so dry unit weight of soil means gamma D. That means weight of dry soil upon volume of dry soil, and weight of dry soil is nothing but weight of solid. Weight of dry soil is nothing but weight of solid. Have you got it? Okay. Now saturated unit weight means this case weight of saturated soil, weight of this soil upon volume of this soil. Guys, density is mass by volume, unit weight is weight by volume. That's it. Density is mass by volume, unit weight is weight by volume. Submerged unit weight means when beyond weight is also acting. Like my density is very high now, but when I am inside the sea, it is also acting there. Okay, similarly, here the gamma submerged when beyond weight is also acting like the soil below water table. It is gamma sat minus gamma W. Of course, not going in derivation in this particular session. Many times I have done the derivation. Okay. हाँ शंकर केंद्र बफरिंग हो रहा है भाई आपका सर आपका सॉइल महामैराथन बहुत अच्छा लगा रिकॉर्डिंग थैंक यू इस फॉर्मूला रिवीजन भी अच्छा लगेगा यार ओके सो गाइस प्लीज क्रोकोडाइल एंड शंकर डोंट डू दिस देयर इज नो बफरिंग आई एम आल्सो वाचिंग हियर इट्स गोइंग स्मूथ गाइस प्लीज चेक Is it fine? Is it fine now? Okay, thank you. Oh, by mistake I said that. I guess it was buffering in between. Okay, sorry Shankar and Crocodile. Okay, now specific gravity of anything is, suppose specific gravity of anything is 2. That means the density is 2 times or unit weight is 2 times of water. Suppose the specific gravity is 3.5. That means density is 3.5 times of water. Or unit weight is 3.5 times of water. Okay, so specific gravity of solid, that is also written as G in all soil mechanics formula. The G is GS, that is specific gravity of solid. Okay, not soil. Specific gravity of solid, that means gamma of solid only solid, not whole soil, because soil includes solid also, water also, air also. Gamma of only solid by gamma of W. Gm now it is not of solid. This is the specific gravity of whole soil, and soil includes solid plus water plus air. So here Gm is the unit weight of soil upon unit weight of water. Like you want G of Abhinav Negi. Like you want if G of Abhinav Negi, then unit weight of Abhinav Negi upon unit weight of water. Suppose you want unit weight of Virat Kohli, or G of Virat Kohli, the unit weight of Virat Kohli upon volume of unit weight of water. So if you want G of solids, so then gamma of solid upon gamma of W. But if you want G of soil, then it will be like this. And guys, whatever G you are using in a formula of soil, that is this one. Guys, I am writing something. Please tell me, have you understood this? Gamma solid will be maximum, then gamma saturated, then gamma bulk. Gamma bulk can be anything, even saturated also. Gamma bulk means whatever the existing condition of soil, might be saturated, might be dry, might be partially saturated. Guys, have you understood this? Please give me yes or no in the comment box. Have you understood this? Give me yes or no. Give me yes or no in the comment box. Give me yes or no in the comment box. Everyone. See, first of all understood this. These all unit weights are of soil. This unit weight is not of soil, this is of solid. Gamma S is solid, that will be highest. Okay, that means it will be highest. These are, see, solid, these are all including soil. Soil means water will also be there, air also there. Water or air, anything will be there. But this is only solid, guys. Come on, yeah. Unit weight of this thing will be very high than unit weight of whole thing. Whole thing is soil. And only this thing is solid. Only if you consider this thing, only this thing, that will be solid. So of course unit weight of this will be more. Because when you are comparing whole thing, then lighter materials like water and air will also be coming. So of course unit weight of solid will be maximum, because it doesn't include the lighter material like water and air. Then saturated will be maximum, then bulk, then dry, and submerged will be least because their beyond weight is also acting. Got it? Now important one, guys, weight of solid is equal to, I am not going in derivation, I have already done derivation many times, more than I guess 7 to 8 times in YouTube. This is particularly formula revision, 1 plus W. What is this W? water content or moisture content, both are same thing. If I divide the volume both sides, weight of solid by volume of soil, that means gamma dry, this is gamma bulk. These all are relations, guys. No need to write down because I'll be giving this PDF in my Telegram group, Civil by Abhinav Sir. Okay, this weight of solid. Now, guys, one more, that N is equal to E upon 1 plus E. N is porosity, E is word ratio, or E is equal to N upon 1 minus N. And one more that is used many times, SE is equal to WG. S is saturation, E is void ratio, W is water content, and G is specific gravity of solid. G is specific gravity of solid. Okay. Now, moving further here, let me just tell you one more thing, that see, gamma of anything, gamma bulk, that is general case, gamma bulk, that is general case, is G plus SE upon 1 plus E into gamma W. In fact, if you divide by gravity, density, you can also write this expression in terms of density. G plus SE upon 1 plus E into rho W. Okay. Now, from here, if it is dry soil, gamma D, then S will be 0. It will be G into 1 plus E into gamma W. If it is saturated soil, then S will be 1. This is the general expression, na? S will be 1. G plus E upon 1 plus E into gamma W. And if you want gamma submerged is gamma sat minus gamma W. So this minus gamma W. So this minus gamma W, if you take LCM, it will be G minus 1 upon 1 plus E into gamma W. And one more thing, even if you write SE is equal to WG, SE is equal to WG, so G you can take common, 1 plus W, 1 plus E. Give me yes or no in the comment section. Give me yes or no in the comment section. Gamma D by gamma W will be G upon 1 plus E. Rishabh Pant. Okay. Now, let's move to the second chapter now, classification of soil. Okay. Not in the second chapter, in the first chapter only. Okay. We can shake this sample. Okay. Suppose we take 1000 gram of soil. 1000 gram of soil. And we shake it. We put the soil, we shake it for 15 minutes. Okay. After shaking it, then above, okay, above there will be, we can weight it. Above there will be high diameter particles, then less, because above are the bigger size sieves. So above will getting the bigger particles, then smaller, like this. Okay. So put 1000 gram of soil, shake it for 10 to 15 minutes, and then after shaking you can measure it, and after measuring you will be getting this. Okay. Now suppose you get a data like this. Okay, you put take 1000 gram of soil, total soil is equal to 1000 gram. Okay, and 1000 gram soil, and these are the sieves. In 1000 gram soil we put it, 1000 gram soil we put it here. Okay, 1000 gram of soil we put it here, and then we shake it. After shaking, there are so many sieves. In those so many sieves, we are getting this much data. Now let me tell you, cumulative mass retained 100, 150. Sorry, 150, 160, 200, 400, 700, 800, 850, 865, 875, 900, 1000. Okay, so percentage of retained, percentage cumulative weight, this is the cumulative weight. Percentage, total weight is 1000 gram. So 100 out of total 1000, 100 out of 1000, 10%. 150 out of 1000, is 15%. 160 out of 1000 is 16%. 200 out of 1000, 20%. Okay, 40%, 70%, 80%, 85%, 86.5%, 87.5%, 90%, 100%, like this. And if you want now percentage finer, which color I take? Like 100 minus 10, 90%, 85%, 84%. I'll tell you logic also. 80%, 60%, 30%, 20%, 15%, 13.5%, 12.5%, 10%, 0%. Let me tell you the logic also now. See, we put 1000 gram of soil and we put the 1000 gram of soil here and then we shake it. After shaking it, of course, after shaking it, the bigger particles will be above, medium particles will be in between, smaller particles will be here. Okay, so bigger particles will be here like this. So we get a data like this. See, now it's very logical now. Suppose 80 mm. What are the bigger particles than 80 mm? What are the bigger particles than 80 mm? 100, because it is retained there. So bigger particles 100 out of 1000, 10%. Okay, if bigger are 10%, the smaller will be 90%, obviously. Suppose I take this data now, 20 mm. So bigger particle than 20 mm. This is retained here and this is already retained. This is even bigger. Okay, at 20 mm sieve, this is retained. And this is retained even bigger, even at the bigger size. So these both are bigger. Okay, at 20 mm this is retained, 50 gram. But already at 80 mm this is retained. So what is the total bigger particles? 150. So bigger particles is 15%. That means smaller particles are 85%. Okay. Now from here we get some data like suppose D60. So D60 is diameter below which 60% particles are there. D30 is diameter below which 30% particles are there. D10 is diameter below which 10% particles are there. And D60 is not always this. D30 is not only this. D10 is not always this. Might be for Bhopal soil like this is the case. Might be Indore soil different answers. Might be my hometown soil, Uttarakhand, different. Might be like now I am coming from Patiala just 30 minutes back. Okay. So might be different case. This is not any fixed answers. That depends on case to case. And might be for Patiala, even 60, 30 and 10 are not coming. Might be here is coming 80, then 50, then 26, then 12.5, then 7. Then we have to do interpolation. Have you got it, guys? Give me yes or no in the comment section. Have you got it, guys? Give me yes or no. Okay. So now percentage finer and log diagraph also we make. Okay, here diameter is decreasing. So we get a graph like this. I'm not going into now well graded, poorly graded, because I'm again and again saying I'm restricting this video as only formula revision series. Okay. So there is a coefficient of uniformity that is D60 by D10. D60 means diameter below which 60% particles are there. Okay. Okay. Okay, thank you, Arun. D60 diameter below which 60% particles are there. D30 is diameter below which 30% particles are there. D10 is diameter below which 10% particles are there. D22.6 is diameter below which 22.6% particles are there. So Cu is D60 by D10 and coefficient of curvature is D30 square by D60 into D10. For a well-graded soil, for sand, Cu should be this and Cc should be this. For gravel, Cu should be this and Cc should be this. Both conditions should be satisfying. Then only it will be well. And what is the meaning of well-graded? Well-graded means bigger particles are also there. Medium particles are also there. So double particles to fill the voids. Okay, and even smaller particles are also there to fill even smaller voids. So X, XL, double L, double XL, triple XL, small, medium, everything is there. So when bigger particles are there, medium particles to fill the voids. Okay, even the smaller particles to fill the smaller voids, then it is compacted, highly densified soil, more strength. That is well-graded soil. that is well graded soil. When all are of same size, that is poor, because then voids will not be, because if all size are same, okay, that means smaller particles are not there that can fit there. Smaller particles are not there that can fit there. So it is poorly graded soil. That is uniform. Uniform means same diameter. That means the smaller particles are not there to fill in the void. That means uniform soil is poor soil. So both the condition has to be satisfied to make it well graded soil. Okay. Now, can anybody tell me on the comment box, for a perfectly uniformly graded soil, for a perfectly uniformly graded soil, what is the value of Cu? For a perfectly uniformly graded soil, what is the value of Cu? Can any one of you tell me this answer on the comment section? For a perfectly uniformly graded soil, what is the value of Cu? अरुण फ्रॉम इलाहाबाद, आपका धन्यवाद. आज लेकिन मैं इतना मोटिवेशन नहीं कर पाऊंगा, है ना, क्योंकि कुछ दिक्कत कैजुअलिटी हुई थी हमारे परिवार में, जिसके कारण से मैं कल पटियाला गया हूँ और अभी थोड़ी देर पहले ही पहुँचा हूँ. तो इसलिए मेरी एनर्जी भी बहुत हाई नहीं है, लेकिन स्टिल क्योंकि आपका एग्ज़ाम है तो इसलिए मैं कल गया. रात भर हम उठे थे और सुबह सब करके अभी आ गए. ओके. फॉर अ परफेक्टली यूनिफॉर्मली ग्रेडेड सॉइल मीन्स कि सबका डायमीटर सेम है, और जब सबका डायमीटर परफेक्टली यूनिफॉर्म, एवरी पार्टिकल इज सेम, एंड व्हेन एवरी पार्टिकल इज सेम दैट मीन्स D60 and D10 बोथ आर सेम. When every particle is same, that means D60, D30 all size are same. So D60, D10 both are same, so it will be 1. It will be 1. Have you got it? Okay. Now guys, suppose when water content and volume I am making, so this is solid and this is air, so this is dry. Now you put little bit water you are putting here. So little bit water, so air and water. Now you put more water, so all the voids are filled with water. That is shrinkage limit, WS. It should be all W, small w. Okay, it is shrinkage limit. Now if you put more water, so volume is now increasing. If you put more water, now volume is increasing. If you put more water, now volume is increasing. So first, volume does not increase, it remains constant. It remains constant because air is reducing and water is coming. Air is reducing, water is coming. Air is reducing, water is coming. After shrinkage limit, when it first becomes fully saturated, then after adding of more water, volume also increases. So shrinkage limit is, so here all there is no air voids. All S is equal to 1. So shrinkage limit is the minimum water content. Shrinkage limit is the minimum water content of all these. Minimum at which saturation is 1. And shrinkage limit is the maximum water content at which volume is equal to VD. VD means dry volume. Okay, so out of these volumes, it is the maximum where volume is VD. And shrinkage limit is also the minimum water content where all saturation value is 1. So this is plastic limit, after which soil behaves as a plastic. And when you are putting more water, it becomes slurry, it becomes mud. So that is liquid limit. Liquid limit, you have put so much water content, you pilpili soil ho gayi hai wo. It becomes liquid. It becomes almost liquid. The shear strength is negligible, 2.7 kilonewton per meter square. Shear strength becomes negligible here. Okay, 2.7 kilonewton per meter square. Can anybody tell me the significance of this? You have seen this. You have seen this many times in books, but nobody told you, neither teacher, neither the book, what is the significance, although I told you that in the marathon. Can you tell me what is the significance of this line? What is the significance of this line? How I can zoom this? Okay, camera क्या कर लेगा? Arrow option, display screen, white screen, blank screen, hide ink markup. Show taskbar. I don't know so much things. What is this line indicates? Let me tell you. Guys, it is not actually that much easy. Okay, it is not like that. If I make this in actual, these are solid particles. Okay, here you are finding it very easy. If these are the solid particles, okay, if these are the solid particles, okay, now if I put water and still it does not become fully saturated, there are some voids, okay, there are some voids. Now see, this void is still left, this is air, but addition of water might not be going exactly at this point. Addition of water might not be going exactly at this point. So addition of further water might be increasing the volume, and even it doesn't becomes fully saturated, this void is still there. So volume even started not at this point, little bit before. Give me yes or no for this beautiful thing. Have you understood, guys? Please put a heart sign on the comment box if you have understood. Please put a heart sign in the comment box if you have understood this. Okay. So WP is the limit, plastic limit, after which soil becomes plastic. W is the limit after which soil becomes liquid. And always remember one trick I am telling you. If E is more, void ratio is more, then liquid limit is more, because if so, those soils which have more voids, that means it can take more water till it becomes fully saturated, sinking limit. Okay, those soils which have more voids will take more amount of water till it becomes fully saturated. So this WS will be very high for them. So if WS is high, because there are so much voids to make it saturate, so this value is increased, that means liquid limit is also pushing. So if E is more, WL is more, here guys numerous questions will be solved now. If liquid limit is high, then permeability will be high, because more number of voids for the same size of void. Permeability will be high. If void ratio is high, that means compressibility will be more. More voids, more it can compress. If voids are more, that means strength will be less. Okay. So with liquid limit, they will be asking these three questions. Then now you can relate. Okay. Now to find the liquid limit, we make a paste. We make the number of blows. From a cassegrated knife, we cut it here. Okay. Then find number of blows. That after how many number of blows it will close. Okay. And liquid limit is corresponding to 25 number of blows. Okay. Now this is consistent index. WL minus WP is also called plasticity, and clay has more plasticity. This is IP, or it is called as plasticity index. Okay, WL is liquid limit, WP is plastic limit, and this W is natural moisture content. So this is IC, consistency index, and this is IL, 1 minus IC. Okay, so what is IC? IC is WL minus W upon WL minus WP. Okay, this WL is liquid limit, this is plastic limit, this is natural water content. Now it becomes very simple that if W is more than WL, that means soil becomes slurry. That time soil is slurry, liquid soil, because the natural water content is more than liquid limit. So at liquid limit, soil becomes slurry. So natural water content is more than liquid limit, it becomes slurry. So when W is greater, that means IC is less than 1. So when IC is less than 1, soil is a liquid state. Easily relatable. Easily this formula is relatable. When IC is less than 0, if this is less than 0, so of course IL will be greater than 1. So liquid state. And as this W is decreasing, so IC is increasing. And W decreasing means it is going to the dry state, to the brittle state. So when W is decreasing, IC is increasing. Increasing when water content decreasing. Water content decreasing means it is going to the dry state, to the brittle state. Dry state to the brittle state, like this. Have you understood this? Have you understood this? Please let me know in the comment section, guys. Everyone out there. Okay. Now IT is toughness index. It is IP by IF. IP by IF. IP is WL minus WP and IF is flow index. What is flow index? From Casagrande, if I make W and log N, water content and number of blows required to close the groove. Water content and number of blows. So when the water content is high, number of blows required will be less. Because when water content is high, that means it is very liquid, pilly soil. So less number of blows will make it close. And when it is dry, less water content, number of blows will be more. So at 25 value, whatever is the water content, that is liquid limit, and slope of this is flow index. Okay. Now this is DR, relative density, E max minus E upon E max minus E minimum, also written as ID. Okay. And this formula is also when void ratio is maximum, then gamma is minimum, gamma D. When void ratio is maximum, gamma D is minimum. When void ratio is minimum, when void is minimum voids, gamma D is maximum. Okay, density will be maximum that time. So Emax is the maximum void ratio, and theoretically the maximum void ratio is given as 0.91. I have proved this value also many times, but I am not going in the proof there. Maximum void ratio is when it is cubical array. Okay, cubical array. It's quite logical. Maximum void will be when you put the other line of solid particles exactly above when you will be putting. That means you are touching at a single contact point. That means voids will be maximum. And if you take any example of 1 meter cube and putting 4 balls of 0.25 diameter, there will be total 8 balls. You will be calculating volume of solids. Total volume will be 1 into 1 into 1 because you have taken a cube of 1 meter side. You can find the volume of solid as there will be 8 balls. 8 into 4 by 3 pi r cube. Okay, and you can find volume of voids by volume of solid, that becomes 0.91. But here in this session I am not wasting time there. 0.9, if nothing is given in the question, Emax will be 0.91, and densest state is in prismodal array. Guys, if you want to put the maximum voids, you will put exactly above, parallel. But if you are having a brain, you will putting the next line of solid particles here. You will putting the next line of solid particles here, where there is so much contact will be there. So voids will be less. Okay, next line will be putting here. So much contact, so voids will be less. So much contact, void will be less. This is prismodal array, and here the E minimum is 0.35. So what this value indicates, that if this value is more, that means E is less. And if that value is more, that means E is less, that means it is densely packed soil. So like here, if it is more, that means that means E is less. E is less means densely packed soil. And as it is decreasing, that means E is increasing. E is increasing means loose soil. Okay. Sensitivity of a soil is the ratio of its strength when it is undisturbed and when it is disturbed. Remolded soil means disturbed. So when it is undisturbed and when it is disturbed, if the value remains same, that means it is not sensitive. Okay, if you are going with a boy, if you are going with a girl and your girlfriend is not causing any change in reaction, it is same reaction, that means she is insensitive of you. Okay, so if the value is same, that means insensitive, koi farak nahi pad raha. If there is some change, there is more sensitivity value, more if this is the sensitivity of that soil. So the biggest chapter we have done formula wise. If you want the complete marathon, I'll put the link here at the below. Okay, now going to the second chapter, that is classification of soil. Suppose you take a soil and more than 50%, more than 50 is coarse grain soil. More than 500 gram is coarse grain soil, that is more than 75 micron. Because more than 75 micron is coarse grain soil and less than 75 micron is fine grain soil. Then it is treated as coarse grain soil. And if more than 50% is fine grain soil, it is treated as fine grain soil. Now if a soil is coarse grain soil, that means if we take 1000 gram, then more than 500 gram is coarse grain soil. Then other three cases are there. Then fines are less than 5%. Fines means fine grain soil. So this case means fine grain soil is fines is less than 5%. That means 96%, 97%, 98% is coarse grain soil. That means if you take 1000 gram soil, then 960 gram, 970 gram, 980 gram, 990 gram is only gravel and sand. Only 10, 20, 30 gram, that is 1%, 2%, 3% is clay and silt. I am talking of 1000 gram. If you have taken total soil is 1000 gram. So here the names are GW, GP, SW, SP. If gravel is more, it will be G. If sand is more, it will be S. WP on the basis of CU and CC that I just showed you. If fines are greater than 5% and less than 12%, means if you take 1000 gram of total soil, that means 920 gram is coarse grain soil, gravel and sand. 920 gram is coarse grain soil, that means 80 gram is fine grain soil. That means 8%. Okay, this case. If you take 1000 gram soil, suppose 900 gram is coarse grain soil, that is sand and gravel. That means 90% is coarse grain soil. That means only 10% is fine grain soil. Okay, that means this case. So here the names are GW, GC, GW, GM, GP, GC, GP, GM, SW, SC, SW, SM, SP, SC, SP, SM. First of all, G means gravel, S means sand, C means clay. Then again S cannot be silt because you are using S for sand. So for silt we use M. So first and third letter will be G if gravel is more than sand. And first and third letter will be sand if sand is more than gravel. WP on the basis of CU and CC. And C and M on the basis of plasticity chart, I will tell you. And if fines are greater than 12%, then the name will be GC, clayey gravel, silty gravel. M means silt, clayey sand or silty sand. Now C and M are based on a plasticity chart like this. This is the A line. A line is IP is equal to points. A line equation is IP is equal to 0.73 WL minus 20. If our point lies above A line, it is clay. If it is below, it is M or organic. Of course, in our course, we only deal with silt. Organic soil and silt both can be there. If you want to distinguish practically in real life, then organic will be dark in color and it loses a significant amount of weight on heating. Because in normal soils only water is heated, but in organic soil, organic compounds also oxidize. Now, suppose let WL is equal to 40 and IP is equal to 20. So put 40 here if you put 40 here, so 40 minus 20 is 20, so it will give 14.6. That means at 40 value, the value is 14.6. But our IP is more. So it is C. See, suppose our IP is 13. So in A line the point is 14.6 and our soil's IP is 13. So it will be M. Now if liquid limit is more than 50, it is high compressible, because liquid limit is more, I just told you. Liquid limit is more, that means more voids, high compressible. Okay, and liquid limit is less means voids are less, low compressible. So here this C or M are decided on the basis of plasticity chart. Give me yes or no in the comment box. Have you understood this? Give me yes or no in the comment section. Have you understood this? Give me yes or no in the comment section. Have you understood this? And here, if more than 50% is fine grained soil, the names are Cl, Ci, Ch, Ml, M or Mi or Mh on the basis of plasticity chart. There is a U line also. U line is 0.9 WL minus 8. It is something like this. U line. If point lies above, it is clay. Okay. If point lies above U line, that means your some values are wrong, because हमारी इंडिया की सॉइल इतनी नहीं है कि वो पॉइंट ऊपर लाई करे. Let me tell you. Suppose AST in examination comes 500 mm square area of steel in singly reinforced beam, 1200 mm square, 2200 mm square we can provide. It's fine. But suppose if AST comes 5 crore mm square in a dimension of beam of normal dimensions, 300 mm depth, not possible. You have done some calculation mistake. Similarly, if the point lies above U line, that means you have done some mistake. But in exam, we don't have to check this. Okay. Check करके करोगे क्या? Data तो same ही रहेगा ना उसके बाद. Now compaction of soil, that is the third chapter. Compaction is reduction of volume by reduction of air voids. We provide some mechanical energy. Usually for clay we provide static energy. For sand we provide vibration, and volume is reduced. Volume reduced means more density, because density is mass by volume. So if volume is reduced, that means more density, because density is mass by volume, or unit weight is weight by volume. Volume reduces, more unit weight means more is the strength. Okay, and when you apply load on a partially saturated soil, always, every time in this universe, always when you apply the load, the air voids reduces first. If sufficient load is there, then all air voids are reduced. Theoretically, because practically there are infinite air voids. And all air voids can't be removed. Okay, but yes, theoretically, on a partially saturated soil, if you apply the load, air voids are reduced, and air void reduction is just instantaneous. In few seconds, air void is reduced. If you apply sufficient amount of weight, a bigger amount of weight, all air voids were reduced theoretically. Practically, there will be a couple of air voids, 2, 3, 5, 10 air voids will be there. If still load is there, then all load, remember this point that is coming from my throat, all load that is coming on a saturated soil, load is taken by the water, and water comes in extra load. Water comes in excess pore water pressure. And when water comes in excess pore water pressure, it dissipates out. So water also starts dissipating out. Okay, and when water starts also dissipating out, so further, guys, the volume reduces. Of course, solid will not be reduced, solid is constant. And this reduction is called as consolidation. So always compaction occurs first. always compaction occurs first, reduction of air voids, and when all air voids are reduced, if there is sufficient amount of load, then load is taken by the water comes in water on saturated soil, all load is taken by the water comes in excess pore water pressure and it dissipates. Hello Swapnil. So this is consolidation. Compaction is instantaneous phenomena. Consolidation takes time because the speed of water is in the range of 10 to the power minus 5, 10 to the power minus 6 centimeter per second. It is not very high. It is not very high. So it takes time. Okay. So this is the difference compaction for cohesive soil. If suppose this is the water content, compactive effort is represented in terms of dry unit weight. Okay, it will be something like this. Okay, here it is optimum moisture content. It is wet of optimum. It is dry side of optimum. Now, why this graph is like this? Let me tell you guys. Suppose you know atta, wheat. To make chapati, you will usko goonte hain sir. You knead the wheat. So if you put a couple of drops of water, nothing will happen. It will not come in the densified form. If you put lot amount of water, then also it will not come. So less amount of water, वो आटा एकदम solid form में नहीं आएगा. And lot amount of water, again it will not come in the solid form. To get the maximum density, we put optimum amount of water in the atta, in the flour. Okay, let me explain this technically to you. That when a small amount of water is added, that means you are adding a lubricant to the soil. Lubricant means which reduces the friction. And when you are adding a lubricant, when you are reducing the friction, then guys, what happens? Whatever the load you are applying, so easily particles can settle because you have reduced the friction by adding the lubricant. So easily the soil can settle. Now soil can settle, that means volume is reduced. That means gamma is increased. So what is happening here? You are adding water. Adding water means you are adding lubricant. Adding lubricant means you're reducing the friction. And when you're reducing the friction, that means easily they can compact. And when easily volume is decreasing, gamma D is increasing. After a particular time, when it reaches the OMC, if you add more amount of water, then there is so much amount of water then where the solid particle has to settle and it will be compacted and volume is decreased, so gamma is increased. There already water is sitting. There is so much amount of water after a particular value that where a solid particle can settle and reduce the volume and gamma D can increase, there already the water is sitting. And we are setting the compaction, not consolidation. So your water will not go out. So after a particular time, there is so much water that it started. The lubricant effect is not that much helpful, and the negative point is more, that volume is increasing. So gamma D will decrease there. Have you got it, guys? Give me yes or no. Give me yes or no, guys. Everyone on the comment section. आटा गूंदने का देख लो ना भाई, कम पानी के साथ भी आटा नहीं गूंदता है ना? दो बूंद पानी के डाल दोगे आटा नहीं गूंदेगा, चपाती नहीं बनेगी. ज्यादा पानी में भी नहीं गूंदेगा. ऑप्टिमम पानी में उसकी मैक्सिमम डेंसिटी आएगी. एंड विद दिस गाइस, the dawn of the engineering mathematics, Ankit sir here in the comment box. So please everyone on the comment section, put a heart sign for the Ankit sir. Put a heart sign on the comment section, everyone, for the Ankit sir. And I already told you at the beginning of the session that Ankit sir, Joshit ma'am, I'm saying Joshi sir and Richa ma'am are coming with the marathons. Guys. Okay, 27th, 28th, 29th. At the beginning of this session, I told you. Okay. Okay. Guys, can you please write down your cities? Okay, hello sir. Ankit sir, मैं भी अभी आया हूँ. कल कुछ बहुत ही ज़्यादा कुछ अर्जेंसी हो गई थी, मेडिकल इमरजेंसी, तो आई वॉज इन पटियाला। कल दिन में गया हूँ, रात भर उठा था मैं, और अभी ड्राइव करके वापस जस्ट 8 PM पे पहुँचा हूँ दिल्ली। ओके, सो अंकित सर इज फ्रॉम वर्धा, आई एम माई होम टाउन इज उत्तराखंड, बट राइट नाउ आई एम इन दिल्ली. ओके, Q2 panda, cute panda. So cute panda, how you know that you are cute? Cute panda, how you know that you are cute? Prayagraj, Vinayak from Karnataka. Where is JNDK? Thakur sahab, where is JNDK? Bijapur, Kadappa. Afrid, where is Kadappa? MH. Okay, Ankit sir, okay. Sure. My pleasure, sir. Swapnil from Aurangabad. Swapnil, I know. Jammu and Kashmir. Suru Thakur, I just, when I am coming to Patiala, I drop my father to the airport and he has been to JNK because his job is there. Okay. Thank you. Thank you, everybody. Let's move further. Okay, guys, now there are some proctor test. Okay. Let me tell you what we do here. It is, they asked that what is compactive effort per unit volume. Okay. So it is, what is effort? On a mold of 944 cc, you are putting a soil, and with 2.5 kg of a weight, you are falling from 305 mm. That is 0.305 meter. And this is happening 3 layers and 25 blows each, not 2.5. So MGH, M is 2.5. One time, when you are throwing 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 one time, what is the energy? M 2.5, G is 0.305, sorry, M is this, H is this, G is 9.81. So MGH, when you're putting something, so MGH. And this is happening how much times? On one layer it is 25 blows. Okay, 25 blows. Then again one more layer, 25 blows. Okay, one layer 25 blows, 25 blows of this, second layer 25 blows, third layer 25 blows. So total it is 75 blows. So this is the energy of one time. This is the energy of one time. Total this is happening 75 times in an experiment. Okay, total this is happening 75 times. So this is the energy into 75 times divided by volume. This is because total energy divided by volume, 944. So from here you can calculate the value. Similarly for others also. Okay. Now let's come back. So we have done this. This is only for ESE, so I'm not doing here. We can do this when ESE exam is there. This we have done. Now I am going to these parts. And let me tell you guys, more than half of soil mechanics is done, because more than half of the formulas are here in this first 3 or 4 chapters, and 25% formulas are in the first chapter only. Okay, so it will not take much time, guys. Okay, moving forward. What is effective stress? में सब concept है यार, सीपेज में concept है, formula नहीं है. Guys, total effect, what is effective stress? इसमें कुछ formula नहीं है यार. This I have derived also, guys. I have derived this also. I have derived this also. But of course, in this particular session, I am not going in derivation. I'll put the link in the bottom of this class. Sigma bar, I have derived as sigma minus u. Effective stress represents what? Effective stress represents the interaction between the particles. That is total stress minus the pore water pressure. And effective stress is high. If effective stress is high, that means it is good. Good. Effective stress is low. That means it is, oh no, it's bad. It's bad in that case. Because if effective stress is high, that means the particle interaction is high and they are not sliding. If effective stress is high, that means particle interaction is high, they are not sliding. If effective stress is less, effective stress represents the contact force. Effective stress is less, that means they are not loving each other. If activity is less, then contact is not much, very less contact, so easily it can slide. If I apply any shear stress here, easily it can slide. But when there is a high contact pressure, it will not be able to slide easily. Okay, that is why the most of the landslides happens in the rainy season. That is why the most of the landslides happens in the rainy season, because this is the formula. In rainy seasons, water table increases, U is gamma WH. So in rainy seasons, this increases, so sigma bar decreases. In rainy season, this happens. And sigma bar decreases, that means less contact surface. And that it means it can have a landslide. That is why in hill stations we have put some holes like this, weep holes. So these weep holes are so that water can dissipate out easily. So the water can cry, water can dissipate out. So water can dissipate out, that means it will not be increasing. That means it is not decreasing. Okay. Now the permeability formula, one formula of the most important formula is that discharge seepage velocity, that is true velocity, is discharge velocity upon n. This is the seepage velocity or true velocity, asli velocity, and this is the discharge velocity. Now what is the difference? What is the difference? Guys, velocity is discharged by area. Velocity is discharged by area. Actually, suppose water is flowing in a soil. So actually if I take this section, then see, suppose these are the solid particles. So water is only flowing through the voids, not the entire area. So this is not the actual velocity, because in this actual velocity they have find Q by A total area. But actual velocity is this, because here Vs is Q by A rho voids, because actually the voids is going, the water is going only from the voids. So this is the real velocity. That is why it is called the true velocity, because it is discharged by area voids, because actually the water is coming from voids only. Okay, and if permeability, suppose this is a parallel to bedding plane. What is parallel, what is perpendicular in that marathon, everything I told you. Here I am not telling you the concepts. For the concepts, the marathon, I will post the link in the comment box later on. Okay, so parallel is K1H1 plus K2H2 plus K3H3 upon like this. Parallel means that head loss from here to here, from here to here, from here to here is same. That whole concept I told you there. Okay. Prince आज तो flickering नहीं किया ना अभी तक. Okay, and this is also arithmetic mean. See arithmetic mean ना, K1 plus K1 plus K1 H1 times plus K2 plus K2 plus K2 S2 times, and this is the total number of values. This looks like arithmetic mean. Okay, and when perpendicular mean discharge is same. Q1, Q2, Q3 all are same. So perpendicular, this is the formula, and this looks like a harmonic mean. And arithmetic mean is greater than geometric mean is greater than equal to harmonic mean. So this K horizontal is greater than K vertical. Okay. Now this is the formula for the empirical formula. What is the guys mean size of particles? This is very important for soil mechanics. Mean size is D50, and what is the effective size of particles? D10. Okay, so mean size is taken as D50. Okay, and effective size is D10. Okay, now this formula, somebody asked that temperature increases, so permeability decrease or increase. So when temperature increases for a liquid, for a gas mu increases, but permeability is related to water, liquid, so mu decreases. So mu decreases means K increases. Now it is also sometimes for K1 by K2 is equal to E1 square by E2 square. Particularly for coarse grain soil, K1 by K2 is equal to E1 cube upon 1 plus E1, E2 cube upon 1 plus E2 from this. Okay. So now seepage, these all are done. Guys, I am again telling you, please Everyone see this. Where is that? Where is that? Where is that? Okay, guys, if you want complete concepts, not only formula but derivation also, you can see this marathon. I will put this. लॉर्डेंस इक्वेशन उतना डीप में नहीं जा रहा हूं अभी फॉर्मूले में, सिर्फ गेट ओरिएंटेड, वो एम्पेरिकल उसमें नहीं आएगा ना आकिब साहब. बाकी लॉर्डेंस इक्वेशन चाहिए तो इसमें मिल जाएगा. इसमें एलन हेजन पोइजी सब कुछ, कैपिलरिटी हेड प्रोबेबिलिटी टेस्ट सब मिल जाएगा इसमें. ठीक है, वही आपको बता रहा था मैं. ठीक है, बाकी ये 27, 28, 29 को मैराथन है, 26 को मॉक टेस्ट है. ठीक है, चलो थोड़ा सा ही बचा है. सी पेज में ना कुछ फॉर्मूला है ही नहीं, मैं खुद ही लिख देता हूं. सबसे पहला तो है कि IC क्रिटिकल ग्रेडियंट इज इक्वल टू G-1 अपॉन 1 प्लस E. अब इसका मतलब क्या होता है क्रिटिकल ग्रेडियंट का? यहां पर जो नेट इफेक्टिव स्ट्रेस होगा वो 0 होगा. क्रिटिकल ग्रेडियंट मतलब यहां पे नेट इफेक्टिव स्ट्रेस 0 होगा. इसका मतलब सॉइल इज इन फ्लोटिंग कंडीशन, उसमें इफेक्टिव स्ट्रेस नहीं होगा. दो पार्टिकल्स के बीच में, अभी फिगर दिखाता हूं, एक बुड्ढे को तैरते हुए दिखाता हूं, अभी समझ आएगा तुम्हें. अच्छा, फ्लोटिंग कंडीशन होगा, इफेक्टिव स्ट्रेस 0 होगा. सॉइल के पास कुछ स्ट्रेंथ बची नहीं लेने के लिए, सॉइल के पास कुछ स्ट्रेंथ बची नहीं लेने के लिए भाई. ये देखो, ये देखो, यहां पर आपके पास इफेक्टिव स्ट्रेस है 0. सॉइल का कांटेक्ट फोर्स नहीं है ना. देखो, दो पार्टिकल्स के बीच में कांटेक्ट नहीं है, दो पार्टिकल्स के बीच में कांटेक्ट नहीं है, कोई कांटेक्ट प्रेशर नहीं है. इसी को अगर आप लिखोगे E को, E क्या होता है n/1 - n, और इसको जब लेके जाओगे तो ये हो जाएगा G-1 × 1 - n. और IC की वैल्यू आपके पास 1 के आसपास होनी चाहिए भाई. अगर 1 के आसपास नहीं हुई IC की वैल्यू तो तुमने कुछ गलती की है. अगर IC की वैल्यू 1 के आसपास नहीं हुई तो तुमने कुछ गलती की है भाई, तुमने कुछ गलती की है. क्यों कम 1 के आसपास होनी चाहिए? क्योंकि G की वैल्यू 2.6 से 2.7 है और सैंड के लिए E की वैल्यू 0.6 से 0.7 है. तो 2.6 के आसपास ये होती है, -1 करोगे तो 1.6, 1.7, और E की वैल्यू भी 0.6, 0.7 होती है, तो ऐड करोगे तो 1.6, 1.7. तो IC की वैल्यू 1 होनी चाहिए. फैक्टर ऑफ सेफ्टी होगा IC/I. फैक्टर ऑफ सेफ्टी होगा IC/I. समझ गए भाई? समझ गए? चलो एक दो फॉर्मूला और ले लो सी पेज में. एक दो के जितने भी है सब दे देंगे भाई, एक दो के जितने भी है सब दे देंगे. समझो, अब मेरे पास सिग्मा बार नेट होता है सी पेज के समय, सिग्मा बार ओल्ड +- HL × गामा W. अपवर्ड सी पेज में माइनस, डाउनवर्ड सी पेज में प्लस. सिग्मा बार ओल्ड मतलब हाइड्रोस्टैटिक वाला, सिग्मा बार ओल्ड मतलब हाइड्रोस्टैटिक कंडीशन वाला, सिग्मा बार ओल्ड मतलब हाइड्रोस्टैटिक कंडीशन वाला. ठीक है, ठीक है, ठीक है भाई. ओके, और डिस्चार्ज क्या होता है? K × H × NF/ND थ्रू अ फ्लो नेट. NF है नंबर ऑफ फ्लो फील्ड्स, ND है नंबर ऑफ इक्विपोटेंशियल ड्रॉप. NF है नंबर ऑफ फ्लो फील्ड्स और ND है नंबर ऑफ इक्विपोटेंशियल ड्रॉप्स. ठीक है, ठीक है भाई कि अच्छा NFND होता क्या है, फ्लो नेट कैसे बनता है, वो मैं उस मैराथन में बता चुका हूं, तो उसको मैं यहां पे नहीं ले रहा हूं। वर्टिकल स्ट्रेस क्या होता है, बॉयजिंग क्या आता है कि Q पॉइंट लोड लग रहा है, इससे Z डेप्थ नीचे और R डिस्टेंस अवे पे कोई पॉइंट P है, Z डेप्थ नीचे और R डिस्टेंस अवे पे, तो इस पे इतना फॉर्मूला लगेगा KB इंटू Q बाई जेड स्क्वायर। जेड क्या है, उस पॉइंट की डेप्थ। बॉयजिंग फॉर्मूला किसके लिए था, पॉइंट लोड के लिए, और जेड KB क्या है, ये फॉर्मूला। ऐसी वेस्टरगार्ड ने अपना दे दिया ये फॉर्मूला। अब वो वेरिएशन कैसे होता है, KB ऐसा रहता है, जब R 0 होता है वो ऐसा होता है, सॉरी वो ऐसा होता है KB, और वो 0.4775 होता है, और वो ऐसा होता है 1.5 पे जब R बाई जेड 1 पर दोनों वैल्यू सेम होती है। वो पूरा मैंने उस मैराथन में बता रखा है, वो पूरा उस मैराथन में बता रखा है। ठीक है, अगर कहीं पे लाइन लोड है तो थीटा किसी पॉइंट P पर जहां से वो दोनों इसके एजेस थीटा पे हैं, तो वहां पे वर्टिकल स्ट्रेस इतना होगा। ठीक है, अगर मेरे को कोई रेक्टेंगुलर लोडिंग है और रेक्टेंगुलर लोडिंग के एक पॉइंट कोने पे है, Z डेप्थ नीचे, P पॉइंट से कोने पे है, तो इसमें जो सिग्मा वर्टिकल होगा पॉइंट P पे वो होगा Q, जितना उस पर सरचार्ज आ रहा है, इंटू I सिग्मा। I सिग्मा एक फंक्शन होगा, बहुत छोटा सा फंक्शन होगा M, N का। M होगा लेंथ अपॉन डेप्थ और N होता है विड्थ अपॉन डेप्थ। तो किसी भी पॉइंट पे, एट एनी पॉइंट, किसी भी पॉइंट पर मेरे पास जो वर्टिकल स्ट्रेस होगा, किसी भी पॉइंट पर मेरे पास जो वर्टिकल स्ट्रेस होगा, वो वर्टिकल स्ट्रेस अपने पास जो होगा Q इंटू आई सिग्मा होगा, Q इंटू आई सिग्मा होगा। ठीक है, ठीक है भाई, Q है उस पे सरचार्ज, उस रेक्टेंगुलर एरिया पे, और आई सिग्मा फंक्शन होता है, छोटा सा फंक्शन होता है M, N का। M होता है लेंथ बाय Z और N होता है विड्थ बाय Z। पर ये फॉर्मूला एप्लीकेबल तभी है जब रेक्टेंगुलर फुटिंग हो, ये फॉर्मूला एप्लीकेबल तभी है जब रेक्टेंगुलर फुटिंग हो, ये फॉर्मूला तभी एप्लीकेबल है जो रेक्टेंगुलर फुटिंग हो और पॉइंट उसके कोने पे हो। और Q इंटू, सिंपल सा फॉर्मूला, Q इंटू आई सिग्मा। आई सिग्मा का छोटा सा फंक्शन होता है M, N का, ये छोटा सा फंक्शन आपको दिख रहा है, छोटा सा, ऑफकोर्स याद नहीं करना है। अब पॉइंट जब अंदर हो, यहां पर हो, क्योंकि Q इंटू आई सिग्मा तो किनारे के लिए एप्लीकेबल है, तो इसको 4 रेक्टेंगल में डिवाइड कर दो। Q इंटू आई सिग्मा ऑफ 1, Q इंटू आई सिग्मा ऑफ 2, Q इंटू आई सिग्मा ऑफ 3, Q इंटू आई सिग्मा ऑफ 4, क्योंकि 1, 2, 3 और 4 चपके ही कोने पे है। और अगर पॉइंट बाहर है तो फिर ऐसा नकली बना लो, फिर उसमें माइनस प्लस खेलते जाना। ठीक है, ऐसी न्यू मार्क चार्ट भी होता है। इक्विवेलेंट लोड मेथड क्या होता है कि तुम्हें यहां पे निकालना है और यहां पे सरचार्ज लग रहा है, तो इसको ना तुम कुछ भागों में डिवाइड कर दो। यहां पे सरचार्ज लग रहा था ना, तो अब क्या करो, इसको ऐसे मान लो, स्ट्रेस लग रहा था Q किलोन्यूटन पर मीटर स्क्वायर इंटू एरिया 1, तो एक Q1 आ जाएगा। Q किलोमीटर पर मीटर स्क्वायर इंटू एरिया 2, तो Q2 आ जाएगा। ऐसे Q3, Q4, Q5, Q6 आ जाएगा। स्मॉल Q स्ट्रेस था, इंटू एरिया 3 कर दो तो Q3 आ जाएगा, Q4 आ जाएगा, Q5 आ जाएगा और Q6 आ जाएगा। तो Q1, Q2, Q3, Q4, Q5, Q6 आ जाएगा। अब तुम्हें कहीं पर निकालना है, यहां पर इसका कुछ Z होगा और इसका R होगा। तो अब तुम इस पूरे को ना 6 पॉइंट लोड समझ लो ना, और 6 पॉइंट लोड समझ के जो तुम्हें बॉयजिंग या वेस्टरगार्ड का इक्वेशन बताया था, बॉयजिंग या वेस्टरगार्ड का इक्वेशन बताया था, वो 6 बार लगा दो, एल्जेब्रिक समेशन ले लो, 6 बार लगा दो, एल्जेब्रिक समेशन ले लो। समझ गए क्या? 6 बार लगा दो, एल्जेब्रिक समेशन ले लो। समझ गए क्या? ठीक है, 6 बार लगा दो, एल्जेब्रिक समेशन ले लो। यहां पे क्या होता है कि ऐसा लोड डिस्पर्शन रेट है, तुम्हें Z डेप्थ निकालना है, यहां पे निकालना है, तो लोड डिस्पर्शन से कुछ 2:1 या 1:2 से यहां का एरिया निकाल लो और यहां का टोटल फोर्स निकालो। टोटल फोर्स क्या होगा, स्ट्रेस क्या होगा, स्ट्रेस यहां पर क्या होगा यार, फोर्स बाय एरिया। तो फोर्स कितना है, टोटल लोड कितना है, वो Q आ रहा है कुछ एरिया पे L इंटू बी पे, टोटल फोर्स अपॉन एरिया ऑफ दिस अपॉन जो इसका एरिया है, लोड डिस्पर्शन से एरिया निकाल लो। यस नो ठोकना कमेंट बॉक्स पर, यस नो ठोकना कमेंट बॉक्स पर, समझे कि नहीं? यस नो ठोकना कमेंट बॉक्स पर, समझे कि नहीं? एवरीबॉडी ऑन द कमेंट सेक्शन गाइस। ओके, अब कुछ मेरे पास आइसोबार्स होते हैं ना, ऐसे 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 कुछ आइसोबार्स होते हैं 0.8Q, मतलब आइसोबार मतलब लाइन जॉइनिंग द पॉइंट्स हैविंग इक्वल स्ट्रेस, लाइन जॉइनिंग द पॉइंट्स हैविंग इक्वल स्ट्रेस। तो इन सारे स्ट्रेस पिन, अगर वहां पे Q सरचार्ज आ रहा था ग्राउंड लेवल पर, तो यहां पे सिर्फ 0.8 ही सरचार्ज बचा, 0.8Q, यहां पे 0.6Q, सपोज यहां पे 0.2Q। जनरली अगर इसकी विड्थ B है तो 1.5 विड्थ पे सिर्फ 20% ही स्ट्रेस बचता है। तो अगर ये 0.2Q है, अगर ये 0.2Q है और ऐसे तुम्हें आइसोबार्स दे रखें किसी सॉइल में, ऐसे किसी सॉइल में तुम्हें आइसोबार दे रखें, ऐसे तुम्हें किसी सॉइल में आइसोबार दे रखें, तो इसका मतलब तुम्हें ऐसा अगर आइसोबार, जैसे तुम्हें राइज एंड फॉल मेथड और हाइट ऑफ इंस्ट्रूमेंट मेथड करने की जरूरत नहीं है, तुम्हें राइज एंड फॉल मेथड और हाइट ऑफ इंस्ट्रूमेंट मेथड करने की जरूरत नहीं है। अगर कहीं पे कंटूर दे रखें तो तुम्हें पता है ना फिर कहां पे कितनी हाइट है। ऐसी अगर तुम्हें कहीं पर आइसोबार दे रखें, ऐसी तुम्हें कहीं पर आइसोबार दे रखें, तो तुम्हें क्या करना है फिर? तुम्हें क्या करना है? तुम्हें तो बस वो पॉइंट देखना है, कहां पे वो पॉइंट आएगा। यहां पे तो 0.8Q, यहां पे तो 0.6Q, यहां पे तो 0.2Q, बीच में तो कहीं इंटरपोलेशन से करोगे। ठीक है, चले कंसोलिडेशन पर। देखो भाई, टोटल सेटलमेंट जो होती है, मैंने अभी भी आपको बताया था कि सॉलिड है, वाटर है, एयर है। सबसे पहले मैंने क्या बताया क्या होगा? सबसे पहले मैंने क्या बताया क्या होगा? कॉम्पैक्शन। कॉम्पैक्शन में रिडक्शन ऑफ एयर वॉइड्स, ये कॉम्पैक्शन है, SI, इमीडिएट सेटलमेंट। इसका फॉर्मूला दे रखे हैं, इनकी टर्म्स भी आगे दे रखी होगी। ठीक है, सब टर्म्स दे रखी है। ठीक है, फिर अब अगर और लोड लग रहा है, सारा लोड कौन लेता है? सारा लोड कौन लेता है? पानी। पानी एक्स्ट्रा पोर वाटर प्रेशर पे आता है, एक्स्ट्रा पोर वाटर प्रेशर पे आएगा तो डिसिपेट होगा। ये वाली चीज क्या है? ये वाली चीज कंसोलिडेशन है, प्राइमरी कंसोलिडेशन है। ये वाली चीज कंसोलिडेशन है, और कंसोलिडेशन में भी प्राइमरी कंसोलिडेशन है। कंसोलिडेशन में भी प्राइमरी कंसोलिडेशन है, मतलब रिमूवल ऑफ एयर वाटर, जिसमें टाइम लगेगा। भाई ये तो इंस्टेंटेनियस है, इसीलिए ना इमीडिएट सेटलमेंट ज्यादा पूछता ही नहीं, क्योंकि एक ही तो फॉर्मूला है। इसका एक और भी है खैर कोजनलेस के लिए, जिसमें CR/C0 आता है, वो मैं लिखा नहीं क्योंकि उससे क्वेश्चन आता नहीं एग्जाम में। नहीं दे रखी होगी ऋषभ पंत, है ना? तो इमीडिएट सेटलमेंट बड़ा सवाल नहीं है, क्योंकि इमीडिएट सेटलमेंट सिर्फ सेटलमेंट पूछेगा। कंसोलिडेशन इंपॉर्टेंट क्यों है, ज्यादा क्वेश्चन क्यों आते हैं? क्योंकि यहाँ पे सेटलमेंट के साथ साथ टाइम भी पूछ सकता है। क्योंकि भाई यहां तो टाइम का मतलब ही नहीं है ना, यहां तो सिर्फ सेटलमेंट हो रहा है, इमीडिएट सेटलमेंट हो जा रहा है, पर से हो जा रहा है। यहां पे यहां पे सेटलमेंट के साथ साथ तो टाइम भी लग रहा है, 2 साल, 3 साल, 4 साल, 5 साल लग सकते हैं। तो यहां पे 2 सवाल बनेंगे। ये तो इंस्टेंटेनियस है, तो सिर्फ ऐसे आ जाएगा। एक CR लॉग वाला फॉर्मूला भी होता है, पर उससे क्वेश्चन आता नहीं, इसलिए मैंने लिखा नहीं। यहां पे इंपॉर्टेंट, ये ज्यादा क्वेश्चन क्यों बनते हैं? क्योंकि टोटल सेटलमेंट भी पूछ सकता है, प्लस टाइम भी पूछ सकता है कि 3 साल में कितना हुआ। अच्छा, टोटल सेटलमेंट 10 है तो 4 साल में कितना हुआ, 6 साल में कितना हुआ। और सेकेंडरी कंसोलिडेशन क्या है कि बहुत ही हाईली विस्कस लिक्विड था, जैम की तरह, बहुत ही हाईली विस्कस था, तो फिर वो तो बहुत समय बाद निकलेगा। या प्लास्टिक रीअरेंजमेंट ऑफ पार्टिकल्स होगा, कि पार्टिकल ही अपने आप रीअरेंज हो रहे हैं 10-15 साल बाद, कुछ ऐसे ऐसे, और जब वो कुछ ऐसे ऐसे हुए तो कहीं का कोई हाईली विस्कस निकल गया। तो दैट इज सेकेंडरी कंसोलिडेशन, जो लगभग इनसिग्निफिकेंट होगा। बाय डिफॉल्ट हम कंसोलिडेशन चैप्टर को प्राइमरी कंसोलिडेशन ही समझते हैं। बाय डिफॉल्ट हम कंसोलिडेशन सेटलमेंट को प्राइमरी कंसोलिडेशन ही समझते हैं। ठीक है, ठीक है, जरा फटाफट से दिल बना दो कमेंट बॉक्स पर। अच्छा सुनो, change in volume by original volume. Change in volume by original volume is delta H by H naught. बहुत ही सिंपल है. Reason is very very simple. एक बार फटाफट से कमेंट बॉक्स में लाल पीला गुलाबी नीली दिल बनाओ भाई, इतने सारे बच्चे हैं कमेंट लिख नहीं रहे. डेल्टा V चेंज इन वॉल्यूम बाय ओरिजिनल वॉल्यूम इज डेल्टा H बाय H नॉट. बहुत ही सिंपल है यार. बिकॉज soil is semi infinite. क्योंकि सॉइल सेमी इन्फिनाइट है. आपने हमेशा सुना होगा कि 2 मीटर क्ले है, आपने हमेशा सुना होगा कि 3 मीटर सैंड है, आपने हमेशा सुना होगा कि 4 मीटर ग्रेवल है, आपने हमेशा सुना होगा, यू हैव ऑलवेज लिसन लाइक दिस, दैट देयर इज वाटर टेबल एट 4 मीटर डेप्थ or there is a clay of 3 meter, there is sand of 2 meter, but you have never ever listened that clay is for 100 meter square area or water table is at 3 meter depth for 200 kilometer square area. No, always we work in terms of depth in soil mechanics. So whatever is the change in volume, that is only due to the change in height, because soil is always semi infinite. Area earlier was also infinite, area now is also infinite. So only change is due to depth. Okay, then that is delta E. This I have derived in that marathon, but of course I am not deriving here. Here we are focusing only on the formulas. Now there is NC soil and OC soil. Let me tell you, there is an over consolidation ratio. Over consolidation ratio is maximum stress in history upon maximum stress present. Okay, so NCC soil has OCR value less than equal to 1. OCC soil has OCR value greater than 1. OCC soil means that the stress you have applied right now is nothing as compared to it was acted by history. NCC soil means the ratio is less than 1. The today's stress is maximum. In history, the maximum stress has not been applied. Today's stress is maximum. Now, why it is very important? The question is this. The question is not this, what is OCR, this, you, everybody know this. The question is, what is the significance here? The significance here is that for a NCC soil, for the same load, settlement will be more, because that much huge amount you are acting first time. For the same load, OCC soil, stress will be less, because it is already acted by a lot amount of stress in the past. Let me tell you, suppose if I am compressing a wheat in a bori, in a polythene I am compressing wheat, and suppose before me nobody has applied load, so it will be settled a lot amount, because it is NCC, whatever the stress is maximum. But if before I am compacting that wheat in that polythene, the great undertaker, big show, has already applied the load or already sitting on that polythene, that my load, the same load will affect nothing. That is the OC soil, because the past the stress is most. Have you got it? Coefficient of compressibility is the slope of E and delta sigma bar, like this. The slope of this is coefficient of compressibility. Y2 minus Y1, that is E2 minus E1, that is delta E upon delta sigma bar. Coefficient of compression is the same curve for NCC soil. If I make in log, earlier it was a arithmetic scale. If the same thing I make in log, the graph looks like a straight line, and here the slope is CC, that is minus Y2 minus Y1, this log sigma 2 bar by sigma 1 bar. Have you got it? Keep sharing, guys. Keep sharing, everyone. Please, everyone, guys. Come on. Now, the coefficient of recompression for OCC soil, this is the CR. For NC soil, it is CC. For OCC soil, it is CR. And guys, even for OCC soil, if I am making, for OCC soil, even if I am making a log graph, it doesn't come straight. And here the slope is CR. And this slope is 1/5 to 1/10 of CC. Of course, this will be a flatter curve. Because OC soil, earlier the Big Show and Khali has applied the load on that. So voids will not be changing much with Abhinav Negi's load. OC soil is that soil in which earlier the maximum load has already been applied. So उसकी settlement हो चुकी है. तो आज कुछ बहुत उखाड़ नहीं पाएगा अभिनव नेगी, क्योंकि खली बिग शोस में पहले ही बैठ चुके हैं, उसमें पहले लोड लगा चुके हैं. तो बहुत ग्रेजुअली वो चेंज होगा, फ्लैट होगा, इसलिए वो बहुत छोटा होगा सीसी से. एवरीबॉडी गिव मी यस और नो. Everybody give me yes or no. Everybody please give me yes or no. Have you understood? Okay. Now, if I'm saying this consolidation settlement, then which consolidation settlement is this? Then which consolidation settlement is this? If I'm saying this as a consolidation settlement, then which consolidation settlement is this? Which consolidation settlement is this? Which consolidation settlement is this? This primary consolidation. Delta H is this and this. If it is CR, OC soil, then instead of CC we'll be using CR. If it is OCC soil, then instead of CC we'll be using CR. This is also written as CC H naught 1 plus C naught log, if I'm saying log, that means base is 10, into sigma naught bar plus delta sigma upon sigma naught bar. Of course, yeah, both are same thing. Initial stress you are writing sigma 1 bar or sigma naught bar, your choice. Later on the stress you are writing sigma 2 bar or sigma naught plus something, it's your choice. Okay, if it is OC soil, you will be using CR. What is MB? MB is coefficient of volume compressibility. And if I am correct, the MB is CV is equal to K upon gamma W into MV. CV is coefficient of consolidation that depends on type of soil. CV is coefficient of consolidation that depends on type of soil. And MV is also AV upon 1 plus E naught. Please check if it is correct or not. I am not very super with memory. Please check, is it correct? Please check, is it correct? Please check, is it correct? Okay. Now, TV, time factor, is equal to CV into T by D square. For single drainage, it is D. If suppose height, if it is the thickness of soil is H. For single drainage, it is H. For double drainage, it is H by 2. Okay, TV is a thing that depends on degree of consolidation. If degree of consolidation is 30%, even for sand, even for clay, even for silt, TV will be same. Because TV only depends on you. 30% consolidation of sand, 30% consolidation of sand of single layer, 30% consolidation of sand for double drainage, all are same. 30% consolidation for clay, 30% consolidation of sand, 30% consolidation of gravel, 30% consolidation of gravel of single drainage, 30% consolidation for gravel for double drainage, all are same because TV only depends on you. So even for clay, even for sand, you will be writing here 0.3. If it is less than 60%, for greater than 60%, this formula. So this CV is coefficient of consolidation that depends on type of soil. D is for single drainage D by D, double drainage D by 2. T is time. Which time? Suppose you are writing this TV for 30% consolidation, 0.3. This is time required for 30% consolidation. Suppose you are writing TV for 90% consolidation. For 90, this formula is not. This is the valid. Then this time will be coming the 90% consolidation time. Time required for 90% consolidation. Got it? Everyone? Please let me know. Please let me know. Have you understood? Now shear strength is coming from C and phi. So shear strength, because why we are considering or focusing more on shear strength? Why we are focusing more on shear strength? Because soil always there is shear failure. Whatever be the type of load, the failure is always shear. One wedge of soil slips over the other wedge of soil. Okay. Now shear strength is C plus sigma tan phi and C dash plus sigma bar tan phi dash. What is C dash, phi dash, and what is C phi? Please see that link, marathon link that I'll be putting here in below. Okay, so of course here I am discussing only formula, not I'm going on beyond that. How this is coming? Okay, sigma 1 is the major principal stress. Sigma 1, this is the soil sample now. We put it in the cell. From all around it is sigma 3. From vertical also it is sigma 3. All spherical stress condition. It is also called sigma confining. All sigma 3. From here, only from vertical we apply sigma d also. Deviatric. Now total from horizontal it is only sigma 3. From horizontal it is only sigma 3. But from vertical it is sigma 3 plus sigma d, sigma 1. So major stress is sigma 1. Okay, this is the formula. Of course, derivation I am not going in this. And 1 plus sine phi, 1 minus sine phi is equal to tan square 45 plus phi by 2. And tan theta is cot 90 minus theta is equal to cot square 90. Tan theta is cot 90 minus theta. So 45 minus phi by 2. Okay, and 1 minus sine phi, 1 plus sine phi is equal to tan square 45 minus phi by 2 is equal to cot square 45 plus phi by 2. Okay, Joshimat video also I already made here. Okay, so Vane shear test, this is the formula. Okay, so Vane shear test, when we apply Vane shear test, guys, suppose the soil is very sensitive. Okay, so very sensitive, that means if we take that soil to the lab, then properties will be drastically changed. Properties of that soil will be drastically changed. So in that case, we test the soil in the field itself. Okay, that is why we put Vane shear test. So those soils, if we put them to the lab, then they are very sensitive, the properties will be changed. So we test in the field, Vane shear test, we put the vane inside. So either when both part, bottom and top part, this is the ground level, and both part are inserted below. So this is the formula. T is the torque required to rotate it. Okay, D and H are the dimensions. So you can find the C from here. It is used for clay. So clay phi is not there, na? For clay phi is not there, na? And here, this is the ground level. Only bottom part is there. Okay, Swami, I am trying that in this week. Okay. So in unconfined compression test, UCS test, you are not confining the soil. Sigma 3 is 0. So the Mohr circle will start from here. Sigma 3 is 0. And this is failing at some stress QU. That is why it is called as compression test. Compression. At how much load it will fail. Because here there is no sigma 3 na, that I told you here. As I told you here, here there is no confinement, no confining stress, no sigma 3. Only sigma d is there. So whatever load is there for failing, that is compression test. That means it is failing at this much compression. It is failing at this much compression. Okay, it is used for clay only. Why for clay? because clay has cohesion. Sand, you cannot make up sample, you cannot prepare a sample without confinement. Sand, the sample will not be there without confinement. You have to apply some load to make it confine. But yes, clay, even with no confinement, it can stand erect because of cohesion. So it is failing at some QU. C is the cohesion, so that is diameter by 2, QU by 2. It is also called as unconfined compression strength. Unconfined sigma 30 compression test. At this much compression it is failing. Okay. Okay guys, have you understood? Yes or no? Yes or no? Now guys, in vertical stress below soil we are finding the vertical stress at a point. Okay, at a point, this is the ground level. Suppose there is some load. This is point P. So we are writing sigma vertical at point P. In earth pressure chapter, we will be finding the horizontal stress. In earth pressure chapter, we will be finding the horizontal stress. Because when these retaining walls are there, guys, in this retaining wall, vertical stress is coming or horizontal? Which stress this retaining wall can fail? At which stress this retaining wall can fail? At which stress this retaining wall can fail? Please let me know. Please let me know. Please let me know. Horizontal stress. So here we will be finding the horizontal stress. Here we will be finding the horizontal stress. And soil is not as homogeneous. Soil is not as homogeneous as water. In water, the gamma H pressure is everywhere. In water, the gamma H pressure is everywhere, all around. Here, the pressure is sigma V, sigma H, and sigma H can be or cannot be same as sigma V. Sigma H may or may not be same as sigma V because it is not as uniform as water. So in water at H height, the pressure is gamma WH, it is all around same. But here it may be different. Okay, now what is that different? Because here we will be finding the horizontal stress. What is that different? So at rest case means when wall is not moving anywhere. So sigma H is K naught into sigma V. K naught, if nothing is mentioned, it is 1 minus sin phi. For elastic condition, it is mu upon 1 minus mu. For elastic condition. Okay, and by default we'll be using this. Of course, there are some other formulas also that depends on over consolidation ratio, but that are not coming in GATE. This is the rest case. Rest case means when wall is not moving anywhere. Now let me tell you the passive case. Passive case means wall moves towards the fill. Here sigma H is equal to Kp into sigma V plus 2C root Kp. Kp is 1 plus sin phi, 1 minus sin phi, also called as tan square 45 plus phi by 2, also called as cot square 45 minus phi by 2. For this is a general expression. For C is equal to 0, cohesionless soil, that is sand, sigma H is Kp into sigma V, and you can see Kp is greater than 1 plus sin phi. So here horizontal is bigger stress, major stress. Okay. Now the active case. Active case means when wall moves away from fill. Wall moves here. This is the fill, away from the fill. That is, and by default this is the case. Because if nothing is mentioned, always guys, this wall will be moving away from the fill. It is not moving towards the fill. It is not, this is not bhoot nahi aa raha hai, ghost nahi aa raha hai. It, towards the fill only it happens in the case of excessive wind loads or earthquake loads. Okay, excessive wind loads and earthquake loads. When it is going towards the fill. Okay. So here guys, are you ready for an oral test? Are you ready for an oral test? Sigma H is equal to K naught sigma V minus 2C root K naught. For C is equal to 0, sigma H is K naught into sigma V. K naught is 1 minus sine phi, 1 plus sine phi less than 1. So less than 1, that means sigma H is minor here. And K naught into Kp are reciprocal. K naught into Kp is equal to 1. K naught into Kp is equal to 1. K naught into Kp is equal to 1. Okay. Got it? Okay, random subject कर लेंगे. And what is depth of tension crack formula? Depth of tension crack 2c by gamma root k. And what is the critical height? Double of this. And what is factor of safety? Critical height by h. But this 2, I told you in this daily dose also. This 2c by gamma root k is not always the correct formula. It is applicable when there is no surcharge. Because this formula is derived, putting the value of sigma h is 0 here. Sigma is 0 here. Okay, k naught into gamma z minus 2c root k naught, z value comes out to be this. This is only applicable when there is no surcharge. Please see this. Okay. So guys, these other things I'll put in the marathon link. There you can see this foundation and slope stability. Will you do that from that marathon if you want formula revision? Okay, I'll share this PDF to you. Will you do that? Will you do that? If you want anything, you can ask me in Telegram, my Telegram. Okay, Civil by Abhinav Sir. Okay. So guys, this is the 2 series we are doing. 2 series we are doing. Yes, Rishabh, you can ask. I'm just asking you the random questions also, oral test. One is prediction series, in which we will be giving you the most 10 expected question. Most 10 expected question tomorrow will be surveying by me. 10 questions guys. Are you coming here? Are you coming here in surveying? Okay. And one is formula marathon series where we are dealing with the formulas. Okay. Now it will be richer mems tomorrow. Environment. Okay. Okay. So this is 14, then this will be on 26th. 26th Jan, Republic Day special. 26th Jan, Republic Day special. Here today some unfortunate incidents yesterday happened in my family. That is why I have to go to Patiala. That is why in today's session I was not able to come. But on 26th I will be coming. Okay, and this is the 3 champions, 3 marathons. The complete verbal, complete mathematics and complete general aptitude. Friday, Saturday and Sunday. 3 champions, 3 mega marathons. So please don't miss that, and this will be after GATE, the non-tech marathon. Now if you want complete Geotech, please watch this. This is 9 hours 55 minutes, I guess. 22,000 views are also there. 22,000 views are also there. 9 hours 55 minutes. Please do watch this. This I've just taken 2 weeks before. From here you can relate this also. क्या कहते हैं उसको? From here you can take the PDF also, na? Okay, now this is the complete, if you want complete 9 hours 55 minutes. You can see this. I am just coming, just don't. Okay, so prediction series and Formula 1 series will be there, guys. Okay, now you can ask your question. Sir, water table in footing question में गामा एवरेज और वाटर टेबल करेक्शन फैक्टर दोनों लगानी है या एक? अगर आपने वाटर टेबल करेक्शन फैक्टर लगा दिया तो गामा एवरेज क्यों लगाओगे? शैलो में कह रहे हो ना? शैलो में कह रहे हो ना ऋषभ पंत? ओके, थैंक यू अरुण. शैलो में कह रहे हो ना? अगर आपने वो DW वाला अगर लगा दिया है फिर उसके साथ कुछ नहीं लगाना है, फिर सेम गामा लेके चल लो. चेंज नहीं करना है फिर गामा को. देखो चिराग दे सकते हैं टेस्ट सीरीज. अगर अभी से आप स्टार्ट करो तो यू कैन गिव 10 to 12 टेस्ट सीरीज. ओके, 10 to 12 टेस्ट सीरीज यू कैन गो. इसके नोट्स चाहिए क्या आपको टेलीग्राम पे? बिकॉज आई गेस अगर आपके पास इस वाले के नोट्स हैं तो फिर इसके नोट्स का क्या करोगे? अगर आपके पास इस वाले के नोट्स हैं जो मैं टेलीग्राम पे शेयर किए हैं तो इसका कोई मतलब नहीं है ना फिर. ठीक है चिराग, पूछिए. इस वाले के नोट्स हैं तो उसी को आप ले लीजिए ना. इस वाले के आपके पास नोट्स हैं तो दैट विल बी मच 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 बेटर, बिकॉज उसमें डेरिवेशन भी होगा कभी कभी. हालांकि हार्ड डेरिवेशन तो 9 घंटे 55 मिनट में भी नहीं हो सकती, टू बी जेन्युइन. इन इफेक्टिव स्ट्रेस अप्रोच देयर इज नो नीड टू यूज वाटर टेबल करेक्शन. हाँ, यस. देखो, सी एवरीवन प्लीज अंडरस्टैंड मी. देयर आर 2 ways टू फाइंड आउट द bearing capacity or ultimate bearing capacity or net ultimate bearing capacity. One by the effective stress approach, in which for a particular depth we write the effective stress if in that zone water is there, and another one is the water table correction factor. From both the ways answer might be little bit different, they are not exactly same. If nothing is mentioned, guys, I recommend you that go for that effective stress wala case, in which we are using the effective stress terms. Suppose in zone B, the zone below the footing, at some part there is water, so that some part, instead of writing gamma B, write gamma into something plus gamma submerged into that B minus something. Okay, if it is specially mentioned that write or do the water table correction, then do that. देखो चिराग, everybody, yes, there is a confusion that when they ask safe load, then should we multiply the net ultimate bearing capacity with the area or ultimate bearing capacity with the area? So guys, in such confusions, believe me, the gate will be asked. If the gate has not correctly giving you the data that it is asking the load other than the soil load, only the load of superstructure, then you will be multiplying Q net ultimate into area. And if it is not clearly mentioned that is it asking the total load including the self weight, including the weight of soil, because if, see, leave all this, if they are asking the total load that can be acted on soil, using ऊपर का लोड भी और सॉइल का खुद का लोड भी, then it answer will be Q ultimate into area. Agree with this or not? First of all tell me. मैं इससे कंफ्यूजन क्लियर करता हूं. अगर उसने पूछा है, if they have asked that, even leave the ask, if we want to find out the total load including the total load that can be acted on soil, the answer will be Q ultimate into area. Yes or no? If they are asking that what load from the superstructure can be applied, that means now the self load, that weight of soil is not there. That means it will be net ultimate into area. Yes or no? Yes or no? And if such things are not mentioned in the question, guys, please don't worry. They will be giving you the marks. Marks to all in that case. Rishabh, that depends on the language of question. That if it is asking of superstructure or total. If it is asking total, then it will be Q ultimate into area. It will be Q ultimate into area. If it is asking total. And if from the question it is not clearly mentioned, I am telling you, in that case, they will be giving you +2. Have you understood this? So, Chirag and Rishabh. Chirag and Rishabh, have you understood this? Chirag, okay. So guys, any more doubt, please let me know. मैं एक बार फिर से बता देता हूँ यार. मैं एक बार फिर से आपको बता देता हूँ, चिराग और ऋषभ को. अगर ओके ओके ZC वाली कैसी लगी थी चिराग? ZC वाली कैसी लगी थी? ओके ले लेंगे इस पे, चलो ठीक है, ले लेंगे. वैसे फिर ले लेंगे, तब तक मैं बता देता हूँ चीज कि अगर इफ यू वांट टू फाइंड आउट द टोटल लोड दैट कैन बी एक्टेड ऑन द फाउंडेशन इंक्लूडिंग द सेल्फ वेट ऑफ सॉइल, इंक्लूडिंग द सेल्फ वेट ऑफ फाउंडेशन, including the soil gamma df also, then the answer will be Q ultimate into area. If you want to find the load that can be acted on the soil other than soil's its own weight, then it will be Q net ultimate into area. Sometimes there is a very big confusion among students, among teachers also, that it is asking the safe load. Find the safe load on the footing. Then of course it is ambiguity. Then safe load should consist of the self weight of soil, because if it is consist of self weight of soil, then we will be multiplying Q ultimate into area. And if it is only the external load other than the soil, then it will be Q net ultimate into area. If from question statement it is nothing mentioned and we are in the ambiguity, in dilemma, do anything. Of course, if answer is not matching, then do another approach. Q ultimate into area answer is not there, then Q net ultimate into area. And if both answers are there, guys, please believe me, they will be giving questions to marks to all. Okay, so thank you guys, thank you everybody. Please, for foundation, see that other video. Okay, there are 2 series, prediction, and I am coming now in the prediction. Tomorrow Richa ma'am environmental engineering and my prediction series of surveying. Okay guys, okay, thank you all guys, thank you all, take care, good night, thank you all.